Okay, let's take a look at solving this initial value problem that a sub n is equal to 5 times the previous term plus 24 times the term that's 2 back in the sequence, and the 0th term is equal to 1 and the a sub 1 term is equal to 2. To do this, I recommend getting everything that has the terms in it on one side, and then from this we can write the characteristic equation. So this was the characteristic equation turns out to be r squared minus 5r minus 24 equals 0. So that's my quote-unquote constant term. This would be my linear term, and that would be the quadratic term. If this was a third order recurrence relation, then it would be a cubic characteristic equation. Okay, so solving this, we get r minus 8 times r plus 3 equals 0, and so this has two roots, two distinct roots. R equals 8 and r is equal to negative 3. And so from this we can conclude that the general form of the solution is going to have the form c sub 1 times 8 to the n plus c sub 2 times negative 3 to the n. Now, to find the two constants, we use the two initial conditions. So a sub 0 is known to be equal to 1, and if I plug in 0, I get c sub 1 plus times 1 plus c sub 2 times 1. So there's my first equation. Then if I plug in n equals 1, that's known to be equal to 2. And plugging in 1, I get c sub 1 times 8 to the first. Then I have c sub 2 plus negative 3 to the first. And so I have two equations and two unknowns to solve for c sub 1 and c sub 2. And so I can use any technique at my disposal that I wish. I can use augmented matrices, I can use Cramer's rule, I can use determinants, I can do a bunch of things in order to be able to solve for c sub 1 and c sub 2. In this case, the easiest thing to do is probably to multiply the top equation by 3, and the bottom equation stays the same. And then I'll add these two equations together. So I get 5 is equal to 11 c sub 1, and so that means c sub 1 is equal to 5/11. Then to figure out the other constant, I'll plug into either equation. Plugging into the top equation is easiest. 1 is equal to c sub 1 plus 5/11, and sorry, got that backwards. 5/11 plus c sub 2, and so that means c sub 2 is equal to 6/11. And so therefore we can conclude that a sub n is equal to 5/11 times 8 to the n plus 6/11 times negative 3 to the n. And so that will be the formula for the closed form solution for this recurrence relation.